Welcome to A Silent Room, featuring real-time interactive voice control. This demo is an adaptation of the legendary incremental game A Dark Room. We use this open source demo as a way to showcase the power and elegance of the vowel Prime 1 voice engine and its ease of integration. Val offers many interesting facets to improve your applications, but today we will focus on 5 relevant to this game: conversational assistance, UI voice control, game state summary, strategy recommendations, and interactive navigations. Okay, let's take a real quick look at how these 5 appear in the gameplay of the demo. Let's join a silent room game in progress and we'll re-engage the Valve voice engine.
Hello, I'm your companion in this silent world.
So, can you tell me what this game is all about?
Sure thing. A silent room starts you in a dark room where you keep a fire burning until a builder arrives. Then you gather wood, set traps, build huts and other structures to grow a village, attract workers, and produce resources. As you expand, you explore the wasteland, mine metals, craft weapons, and eventually build a spaceship to escape.
Okay, can you stoke the fire?
Fire stoked. Let me know what you'd like to do next.
Talk to me about my current game status.
You're outside now. The fire's roaring, and you've got a full village of 80 people. You have over 214,000 wood, plenty of fur, meat and leather, and a solid iron stock. All basic buildings are built: 10 traps, a cart, 20 huts, lodge, trading post, tannery, smokehouse, and workshop. No miners or steel-related structures are unlocked yet, so you can't craft metal weapons until you explore and find the iron and coal mines. Let me know what you'd like to do next.
Okay, do you have any recommendations on what I should do next?
So you've got a solid base and lots of wood. First, head out and explore the wasteland until you locate the iron mine and the coal mine. Those unlock iron miners and coal miners. While you're out, check your traps regularly for fur and meat, and keep stoking the fire when you return. Once the mines are secured, build few iron miners and coal miners. Then open the steelworks.
I'd like to go back to the room.
We're now back in the room with the fire still burning. What would you like to do next?
I'd like to go to the village.
We're in the village now, ready to gather wood, build, or assign workers. What would you like to do?
Before we jump into the technical overview, let's talk about Val's value proposition. Now, traditional voice agent implementation usually requires managing WebSocket connections, parsing JSON messages, routing function calls through conditionals, handling errors, formatting responses, and keeping state in sync. Now, this can lead to lots of boilerplate, brittle event loops, and a maintenance nightmare. Each new action means more conditionals, more parsing, and more places for bugs. With Val, let me just show you here. Um, you define actions declaratively, describe what the action does, provide parameters, and write the logic. Val handles the event loop, function call parsing, response formatting, error handling, and state synchronization. What took 50 lines of boilerplate before becomes a single register action call. This framework handles the infrastructure so you can focus on game or application logic. This reduces code by 80% and makes voice control as simple as defining a function. Conversational Assistance enables natural dialogue about game mechanics, objectives, and strategy. The architecture splits into 2 modules: System Instructions and the Strategy Guide. System Instructions define the assistance role, game overview, core resources, and critical rules. The Strategy Guide provides phase-by-phase progression, building priorities, combat tips, and advanced strategies. These live in two files, system instructions.js for the base prompt and strategy guide.js for the strategy content. The system prompt combines a base prompt with a strategy guide. The base prompt establishes an assistance role and covers game progression from the dark room through the village building, wasteland exploration, and spaceship construction. The greeting system selects from varied phases like "Welcome to a silent room, I'm here to guide you," or "I'm here to help you survive," to personalize each session. The strategy guide includes phase-specific guidance, early game fire management, mid-game building priorities, late-game exploration tactics, and in-game ship construction, so the assistant can provide context-aware advice based on the player's current phase. UI voice control translates natural commands like stoke the fire and build a trap into game actions. The architecture is modular. There's 7 action modules which handle room actions, resource gathering, building, worker management, trading, combat, and events. 3 utility modules provide cooldown management, action tracking, and navigation helpers. This separation keeps each action focused and maintainable. Each action follows a consistent pattern. Take stoke the fire. It automatically navigates to the room if needed, checks if the action recently succeeded to avoid duplicate calls, validates cooldown timers, and executes the game function and tracks success. Actions like gather wood and build follow the same pattern. Automatic navigation, cooldown checks, validation, clear success or failure messages. The cooldown helpers prevent spam, action trackers cache recent successes, and navigation helpers ensure players are in the right location before executing commands. This means players can say build a trap from anywhere, and the system handles navigation, validation, and execution automatically. Game State Summary provides real-time access to game data. The architecture uses 2 components, status actions and state helpers. Status actions expose query endpoints that were made available in the original Darkroom game, like get game context, get resources, get buildings, and get population, while state helpers provide utility methods to read location, game state, resources, buildings, population, and worker information. These functions live in status actions.js and game state helpers.js respectively. The primary tool is Get Game Context, which aggregates current location, resources, buildings, buildable structures with cost and availability, worker requirements, population data, and active events. It computes buildability, checking unlock status, resource availability, current counts, and maximum limits. So the AI knows exactly what can be built. The Game State Helper class provides focused methods such as Get Current Location, which reads the active module, Get Game Status State, which returns fire status, temperature, time, season, population, and reputation, while Get Resources and Get Buildings format data for easy consumption. This means when a player asks, "What should I build?" the AI has complete context to make informed recommendations. Game strategy recommendations provide strategic guidance based on current game phase, resources, and objectives. The architecture combines a strategy guide document with context-aware analysis. The strategy guide covers 5 phases, from the dark room through village building, exploration, mining, and starship construction, plus perks, weapons, progression, advanced strategies, and quick reference tables. Context-aware analysis uses get game context to read current resources, buildings, and population, then applies the strategy guide to recommend next steps. The strategy guide is embedded in strategy guide.js. It includes phase-specific priorities, building sequences, resource conversion chains, unlock requirements, combat progression. The AI integration workflow combines this static knowledge with real-time data when the player asks, "What should I build?" And the system calls get game context to get current state and identifies the phase from building and resources, references the strategy guide for phase appropriate priorities, and recommends the next logical action with reasoning. This means recommendations adapt to the player's exact situation, whether they're early game needing huts and traps, mid game preparing for exploration, or late game optimizing for the starship. The guide also includes advanced strategies like speedrun tactics and challenge modes, giving players depth, whether they're beginners or experts. Interactive navigation enables voice-controlled movement between game locations using vowel's built-in navigation adapter. The system centers on Game Navigation Adapter.js, which maps URL-style paths like room, outside, village, world, ship to game modules and uses engine.travel to switch locations. The adapter provides a navigate function that translates natural language commands like go to forest or navigate the village into module transitions. And it checks if the player is already at the destination and handles errors when locations aren't available yet. Navigation is integrated into all game actions through helper functions like ensure room or ensure outside, which automatically navigate to the required location before executing an action. For example, stoking the fire automatically moves the player to the room if needed. For the Wasteland exploration map, specialized actions like get wasteland surroundings, navigate to POI, and go home provide advanced pathfinding capabilities, allowing players to discover nearby points of interest, navigate to specific landmarks by ID, and return to the village while automatically checking resource requirements for the journey. Throughout this video, we have covered 5 voice control paradigms: conversational assistance, UI voice control, game state summary, game strategy recommendations, and interactive navigations. These were enabled by many functions specific to the Silent Room demo, and some reference the game API from the original Darkroom game. Now, it's important to note here that because Val's interface is concise, modular, and well documented, most of the imperative Val code shown here was generated by a coding LLM. And we did this by using Val LLM rules document in a Darkroom game interface document. So this demonstrates that with solid application documentation, the AIs can generate most of the functions needed to navigate and use your application via interactive voice. So in other words, it's the ultimate dream: machines building machines. Now we have included GitHub links to the Silent Room game code and to the architectural overview document referenced in this video. We thank you for watching, and we hope you enjoy using Val as much as we enjoyed building it. Thanks again.